Hi everyone, welcome to this channel. Today we are going to do summary for the lesson in week 1 and week 2. What will be contained in this short video? Basically, we want to make it clear about what is the isotope notation, and from the isotope notation, how we're going to determine number of electrons, protons, and also number of neutrons. Next, we will try to get the difference between the average atomic mass and also relative atomic mass, followed by the to determine the percentage abundance for an isotope. Then next, we will go to next subtopic, which is about empirical formula and also molecular formula, and where we will guide you how to get the mass of the element before you go for the next step. And last, we will going to have a quick revision about solute, solvent, and also solution. Let's start with the isotope notation. Let's say you are given this isotope notation. So from the isotope notation, 31 is the Z number, which we have the idea that it is proton number. Since there is no charge over here, means that the number of electron also 31. So to get the number of electron, we will going to use the atomic mass minus with the proton number, which will have the idea that it is 39 neutrons in this atom. Next, Be2 plus, this one represents an ion when it is with the charge, and this is a cation ion. So the number of proton is 4. Due to it is positively charged, means that number of proton is more than electron. So as we know, proton always has 4 and they has extra 2 proton from the electron. So from here we will know that the number of electron is 2. So but the number of neutron is 9 minus 4, which is equal to 5. How about if it is an anion with the negatively charged? So again, we compare proton with the electron. This time we know the number of proton is so this time we know the number of proton is less than electron. And the number of proton is given in the isotope notation, which is 15. And electron is have extra 3 compared to proton, means that there is 18 electrons. And the number of neutron is 31 minus 15, which is equal to 16. Next, let us look at what's the difference between average atomic mass. Let's say the question asks you to calculate the average atomic mass. Based on this term average atomic mass, we will know that the final answer with the unit. And the unit can be in unit or can be an atomic mass unit, AMU. So the formula used to calculate the average atomic mass is the so-called chemical. So you just substitute value accordingly and make sure the final answer with the unit. If the question asks you to calculate the relative atomic mass like here, let's say the words average is changing to relative atomic mass. For this question, even looks similar and the final answer of the value is same for these two questions. But the working step is slightly different, where if the question asks you to calculate relative atomic mass, basically there are two steps. Step 1, you will use the formula of chemical to determine the average atomic mass with the unit. Next, you use the formula of relative atomic mass to cancel out the unit and simplify the value, which your final answer is without unit. Okay, let's continue with the last part of the week 1 lesson, where we always have to emphasize that the total abundance for an atom always equal to 100%, and the formula that we always use in determining the percentage abundance or the atomic mass or average atomic mass, we always use the formula chemical. One formula always have one unknown. Now let's look at the question of slide 44, which is in your notes with the title or exercise 1. Let's read this question. Copper has two isotopes, which is 63 with the mass 62.9692. So we know mass is given, and also the abundance, which is the 69.17. And then they ask us to determine the atomic mass for another isotope. So as we know, we are going to use the formula average atomic mass of copper equal to chemical. So there are two isotopes. First isotope, as we saw in the question, is copper 63 with the mass 62.9296 and the abundance is 69.17. So we multiply with the 62.696, and then definitely it's very obvious that we have no atomic mass for another isotope, because the question asks us to identify the atomic mass for another isotope. So it means that the mass is unknown. Okay, but then how about the abundance? As just now we mentioned that the abundance always is equal to 100%. So means that the abundance for another isotope will be used 100 minus with the 69.17, which will equal to a 30.83%. And then divide by the total abundance always equal to 100. So means that we still have one more unknown, which is the average atomic mass. So if this happened in your test or in your exam, then you have to refer to the list of the element, and where you will notice here the atomic mass, the relative atomic mass for copper is 63.6. So which is what we mean just now, one formula always have one unknown, which is the mass for the other isotope. Okay, in second week, we learn about how to determine the empirical formula and also molecular formula. So among the working steps, we always emphasize the step of mass of element. If we can identify the mass of element correctly, basically there should be no problem to get the correct answer. So now let's look at slide 63 in your notes. So you will notice that in this question, the information about the element is given in percentage. So if the question is given in percentage, we have to make a statement over here. Assume the mass of the sample is 100 grams. Okay, next, sometimes you may notice that the question may give us the mass of the element directly, like here, 4 grams of calcium, 7.1 grams of chlorine, 7.2 grams of water. So if the question is give us the terms hydrated, do remember that it is related with the H2O, like this here. Okay, another type of the question that will be given is like this. Slide 66, they let you have the mass of carbon dioxide and also mass of water. So from mass of carbon dioxide and mass of water, we can use the 12/44 multiply with mass of sample of carbon dioxide to get the mass of carbon. Then similar condition towards to the mass of hydrogen in water, and where we use 2/18 multiply with the mass of sample of water. So then how you get the mass of oxygen, since the question let us know that the compound consists of carbon, hydrogen and oxygen. So we will going to use the mass of sample, which is the 1 gram minus the mass of carbon and hydrogen. So we know that the remaining mass will referring to the mass of oxygen. Okay, based on the previous slide, we generally have idea that there are 3 different type of question, which how they share the information of mass to us. But if you go through to the question or also your notes, we will basically notice that the question in metric always more focus on the combustion data. So let's, for example, how we know the question is given us the combustion data. For example, you can see that there is mass of carbon dioxide, mass of water in exercise 2. Similar to exercise 3, we have the mass of carbon dioxide, mass of water. Okay, based on this exercise 2 and exercise 3, you will notice that they let us know the element in the compound is carbon, hydrogen, oxygen. And here also have carbon, hydrogen, and oxygen. So no worry about. So after we get the mass of carbon and hydrogen, then we can use the mass of the sample minus the mass of carbon and hydrogen that we calculated before. Okay, so for another exercise 4 here, this one they are not given us the combustion data, but they give us the mass of carbon and hydrogen directly. But still the similar case, you will use the mass sample minus the mass of carbon and hydrogen to get the mass of oxygen. However, you have to always remember that in commonly we will always say the sample contain carbon, hydrogen and oxygen. But there's sometimes maybe the compound not just contain carbon, hydrogen, but with another element. For example, this question, compound Q contain carbon, hydrogen and nitrogen, okay, which is slightly different from the previous question. So do take note about this. Okay, last part of this video is the concentration measurement. So as we know in the tutorial class, first thing we must remember the formula of the concentration measurement. Just remember formula is not enough, as when we read the question, we need to get the idea whether for this question we need to do assumption or no. And from the question, you have to identify the information given is referred to solute, solvent, or solution. Okay, let's look at the question, exercise 5 in your notes. Calculate molar concentration. So if you have no idea the formula of this molar concentration, means that you cannot continue. So again, would like to emphasize, remember the formula is very important. Okay, let's say you already know the formula of the molarity, which is equal to mole of solute over mass of solvent. Okay, so please don't remember mole over mass. You must remember mole of solute over mass of solvent. Okay, to remember the formula like this is correct. But if you remember the formula mole over mass, this is the wrong way that you remember the formula, because later you will have no idea which number of mole that you need to substitute in the formula. Okay, then we continue read the question. By dissolving 0.3 mole of copper 2 chloride in 40 mole of water. So when you read this question, you will get the idea. Copper 2 chloride is the solute and water is the solvent. Then now it is very important and easy for you to substitute the value correctly. So mole of solute refer to copper 2 chloride. So you know you will substitute 0.3 mole here, but not 40 or total up 0.3 with the 40 over the mass of solvent. So here we also know that we need to determine the mass of water. No worry, because when we have mole and also the molar mass, so we will able to determine the mass. So the mass will equal to number of mole multiplied with the molar mass of the water, and then again, don't forget that the mass must be in kilogram. So here is in gram, so we have to convert this unit later to kilogram by dividing with 1000. So like this, we will able to get the answer. So I hope in this video, you have the idea that how important the formula for the concentration measurement, and also how important that you need to identify the solute, solvent, and solution in the questions. So I will see you in next video. Bye bye. In your notes,